Hello guys, welcome back. Today we are going to look at on how to express complex number to polar form. We have the range, which is 0 degree. Theta it is greater than or equal to 0 degree, but less than 360 degree. So the angle which they are to find does not reach 360 because they have used less than 360. In case they have added or equal to, you have to find until 360. So let's get started with the question 1. Question A, it is minus 3 plus 4i, which is imaginary. Then B, minus 7i, which is imaginary. So we have to take these equations in complex number, take it into polar form. And the standard formula for finding the complex number, it is z equals a plus I b, right? Where a represents the real axis, which is the x-axis. Then 4i represent the imaginary number, which is in the y-axis. So we have to take this equation into this equation here, which is z equals r open bracket cos theta plus I sin theta. So we have to take this equation into this equation here. So how do we take this complex number into polar equation? So we have to draw imaginary, then x-axis it is real axis. Then here we have a 0. So if you can see from our question here, we have minus 3 and 4. Minus 3 and 4. Minus 3, like I said, this lies on x-axis, which is a real axis. So here we have a 3. Here we have 4 here. So we have to draw a right angle triangle here, which will look like this one with a 90. Then here that means we have a 4. Then here r. So now we have to find the value of r by putting this one in modulus, which is minus 3 plus 4i. The modulus, it will be equals to root of a squared plus b squared. This a squared will represent x-axis, which is a real axis. So in which it will be a, we have minus 3, right, which is minus 3 squared. Then plus b, we have 4, which is 4 squared, right? Then in which it will be equals to minus 3 squared, it is 9, plus 4 squared, it is 16, right? Then root of 9 plus 16, which is 25. Then the root of 25, it is 5. So we only get the positive answer because here we have a positive and negative, in which we only consider the positive one. So this is the radius r. And remember that when you are dealing with the vectors, we all know that y component, it is denoted by r sin theta, right? Then x component, it is denoted by r cos theta, right? Then in which we are going to say, we are going to use this formula, which is z equals, which is here. So z equals where we have where there is a, because the standard equation for complex number, it is a plus ib. So where there is a, we have this is our a here, then b here. So a, it is r cos theta, right? Then plus y, it is on imaginary number, so you have to write I sin theta, right? Here we have r, in which we are going to factor out r, which is r outside. Then cos theta plus I sin theta. Then now we have already found the value of r, which is 5, so we have to substitute here 5, then cos, then here we have to find the angle. How do we find the angle? We are going to do a tan. We all know that tan theta it is equals to sin theta over cos theta. From this equation which we have here, sin theta it is b, which means we have 4. We have 4, right? Which is equals to, so because of this negative we are going to have minus 4 over 3, right? Where there is a, we have minus 3. This is how it came. Then in which we are going to do theta equals tan inverse of 4 minus 4 over 3. Then when you punch on calculator, the angle you're going to get it is 53.13 degree. So this angle is only here. So the angle what we are looking for, it is from here to here, right? In which we are going to say 180 degree minus the same angle, which is 53.13 degree, which is equals to 126.9 degree. So this is the angle which we are going to use in this equation here. So in which it will be r or z here equals r. Where this r we have 5 here. We have 5, then open bracket, then cos. So we're going to use this angle here because the angle should be less than 360. So we're going to use the same angle, which is 0.9 degree plus imaginary, which is sin 126.9 degree. This is how we express a complex number into polar equation. This is the polar equation, which is z equals 5 cos 126.9 degree plus I sin 126.9 degree. This is a polar equation. So now let's find minus 7i. And we all know that the standard formula for complex number, it is z equals a plus ib, right? In which a here it is not appearing, so that means here we have a 0 plus ib, right? In which ib we have minus 7, so it will be 0 minus 7i. So now if you reach here, the second step, we have to find the radius. Now how do we find the radius? So we are going to draw, then this is the real axis, which is x, and here we have a 0. So we have to do like 0 minus 7i, the modulus, which is equals to the square root of a squared plus b squared, which is equals to a 0 squared plus b, we have minus 7 squared, right? In which 0 squared it is 0 plus negative 7 power 2, which is 49. In which 0 plus 49 it is 49, which is equals to 7. So we only correct the positive ones. So now we have found that r it is 7, and the standard formula for polar equation, it is z equals r open bracket cos theta plus I sin theta, right? In which we're going to say, we're going to follow this question. We have minus 7. So where is minus 7 on imaginary? Imaginary lies on y-axis. So minus 7 it is here. Minus 7 it is here. So we are moving from 0 we are moving from 0 to where minus 7 is. So this is where angle is, which is 270 degrees. So this is our angle which we are going to use. So it is going to be z equals r, we have found that it is 7, open bracket, then cos theta, we have found that it is 270 degree plus I sin theta, it is 270 degree close. So this is the polar form equation. Thank you for watching. Don't forget to subscribe and turn on the notification bell so you next time I see the new update.